Hello elements, I am doing this short podcast on calorimetry or designing a hand warmer lab because I saw a lot of confusion today. So first of all, you were trying to do two things today. You were trying to do part A and part B of this lab. In part A of this lab, you were trying to get some practice with your procedure. And your idea was to get a value of change in temperature per gram of magnesium sulfate. And if you recall, you used 5 grams of magnesium sulfate. So if your temperature change, let's say, was 15 degrees Celsius, then your value is around 3 degrees Celsius per gram. The range is, for most of the kids, they are getting between 1.5 to 3.5 degrees Celsius per gram. Anything within that range is good. Little above, little below. Little below means you're losing a little too much heat. You've got to be careful with your technique, making sure that there's no heat loss. Too high, you are reading something wrong. So make sure that your thermometer is right. You're putting the lid on really fast. And most of all, you are only measuring the temperature after the temperature has become constant. And all the mixings and all the temperature readings should be done after the mixture has been stirred. So your calorimeter should constantly be on the stirrer with the magnetic stirrer in there, so your solution's temperature is even throughout. Now moving on to part B, that's where a lot of you are very confused. And in part B, what you wanted to do was to figure out, let me just erase this thing from here. You wanted to figure out in part B, what is heat capacity of calorimeter. Heat capacity is an intensive property, meaning that there is no mass component to it. So heat capacity is written with uppercase C, and it is calculated by heat of calorimeter is equal to its heat capacity times delta T. As you notice that there's no mass unit, and C's units will be Q's unit over delta T's unit, which is joules per degrees Celsius. For this part, you had 3 measurements. Let me make up some number. You had initial temperature of water. Let's say it was 20 degrees Celsius because it was at room temperature. Then you heated up the water to 50 degrees Celsius. And let's say you took 100 mils of water here and 100 mils of water here. So if first law of thermodynamics holds good and you lost no heat to the atmosphere, then heat given by hot water plus heat accepted by cold water plus heat accepted by calorimeter should all be equal to 0. Or in other words, whatever heat is being given by hot water should be taken by cold water and calorimeter. If you had ideal conditions, then the hot water should give off heat and cold water should absorb heat. But in addition to cold water, because it's a real situation in a real laboratory, part of the hot water's heat also goes towards calorimeter. So the purpose of finding heat capacity is to gauge how much of the total heat given from the hot water is going to the calorimeter. And the formula here is heat of hot water is mc delta T of hot water plus mc delta T for cold water plus Q is C times delta T for calorimeter. Now mass of hot water is 100 grams. C for hot water and cold water is same, which is 4.184 joules per gram degrees Celsius. Delta T for hot water will be final, let's say, sorry, this was initial for hot water, this was initial for cold water, and let's say your final temperature was 30 degrees. So delta T here will be 30 minus, I forget my suffix, 30 minus 50 degrees Celsius. Okay, so that'll be 100 times 4.18 times 20, right? I'm not going to solve it. You can solve it using your calculators. But I'm showing you the methodology. Plus cold water. 100 grams times 4.18 joules per gram degrees Celsius. Now delta T for cold water will be initial temperature of cold water was 20, but final was 30. So final 30 minus initial 20. Plus heat capacity is unknown, and delta T for calorimeter will be final. Calorimeter will have the same temperature as the mixture of water, minus initial was room temperature water. And when you solve this for C, you will get heat capacity. The ideal range for heat capacity is between 15 to 35 joules per degree Celsius. But I will accept little variation in this because I understand that you are coming from different places. I thought this calculation will help clarify some of the confusion. I will upload this screencast and send you an email message to check this screencast. Thank you for listening, guys.